Bienvenidos, Ushamdi, and welcome to this HUT8 networking Techtorial deep dive on BGP Cost Community and MPLS L3 VPN networks with EIGRP as the PE to CE routing protocol. In this video, you're going to learn all about the BGP Cost Community. You're going to learn why the BGP Cost Community was created as an extended community attribute in BGP, and what role does the BGP Cost Community play when EIGRP is being used as the PE to CE routing protocol in MPLS Layer 3 VPNs. So let's first start out by talking about what is the BGP Cost Community. Well, as I've already stated, it's just another BGP extended community attribute. There are many extended community attributes that we're already familiar with. One of those would be a BGP route target. Now, the route target is an extended community attribute, and in my previous video on OSPF as the PE to CE routing protocol, we talked about a whole host of BGP OSPF extended community attributes, and that video specifically talked about the route type. And so this is how BGP in an MPLS Layer 3 VPN scenario does its best job or makes a best effort to gather up all of the IGP characteristics and bundles them together as BGP extended community attributes in that VPN v4 update that's going to be sent across the service provider cloud. Now, the BGP Cost Community is made up of the values you see here in this diagram. The first value is simply the type, which identifies this extended community as the BGP Cost Community. Next, we have the POI, or Point of Insertion. Now, the actual value and what we're going to be looking at by default when we're working with EIGRP as the PE to CE routing protocol and we redistribute that EIGRP network layer reachability information into BGP, where it becomes a VPN v4 update, by default, the value that we're going to see for the point of insertion is going to be 128. But we're not actually going to see 128. We're going to see some text, and it's going to say pre-best path. And that is really what the BGP Cost Community is all about. So the point of insertion causes a lot of confusion because you'll hear individuals talk about the point of insertion as if it's mutually exclusive from the BGP Cost Community, as if point of insertion is its own feature, when in fact, the point of insertion is nothing more than a single octet value that is part of the BGP Cost Community. So that's what point of insertion stands for. And I'm going to talk a little bit more about the different values you might see by referencing the IETF draft Ratana BGP custom decision. Now, the two authors here are both legends in the routing space, Alvaro Ratana and Russ White. And they were the authors of this document back in May of 2011. Now, I stress it's a draft because it was never standardized. However, Cisco still went ahead and implemented the BGP custom decision process, but they call it the BGP Cost Community. And so the reason for that is if we come down here to section 3, if I scroll down a little further, and the document's very short, it's a great read, you can see right here that section 3 of the BGP custom decision process IETF draft is titled BGP Cost Community. And it calls out that the BGP Cost Community is an opaque extended community. And it's defined as follows. You have the type field, and we've called out 0x43 as our value in the diagram that I have up. And then underneath the type, the the draft, the IETF draft, lists out the value fields. And I've done mine in my drawing, instead of stacking them to try to make it a little easier to look at, I've done it from left to right. So here's our type value of 0x4301, the point of insertion value, the ID or the cost community ID, and then the cost, which is 4 octets. And so they stack theirs in the IETF draft. I've drawn mine out looking at it from left to right. So we've got the point of insertion, right? The POI, the cost community ID, both of those are single octet values. And then we have the cost. And so let's talk about these in turn. You can see that the draft says the point of insertion subfield contains the value of the path attribute after which this community must be considered during the best path selection process. Now, I've called out that we're talking about this in an EIGRP being used as the PE to CE routing protocol. So typically the first question learners ask is, well, wait a second, if it's EIGRP that's being used as the PE to CE routing protocol, why is the cost community associated with BGP? And to talk about that, we would first need to look at the BGP best path selection algorithm. Now, this document is one of the seminal documents in the Cisco documentation library that talks about the BGP best path selection algorithm. And you're probably very familiar with wait and then local preference, and then if it was originated locally as opposed to, excuse me, as opposed to not being locally originated, and then we go to the AS path. And this is how BGP functions. And this is critical to understand what the BGP cost community is going to allow us to do. Now, remember from the title of this presentation that it's about the BGP cost community when EIGRP is being used as the PE to CE routing protocol. And I'm going to tag a little addendum onto that because I couldn't fit it all on the slide. And we have an EIGRP backdoor link involved. And so I'm going to jump on the command line here in a second, and we're going to walk through all of this in great detail. But again, for foundational purposes, the BGP cost community is talking about where that value, the BGP cost community metric value, would be evaluated in the BGP best path selection algorithm. So as you can see here, this is how BGP normally works. It's first going to evaluate the weight. Then it's going to look at the local preference in order to determine which path is the best. Now, number 3 becomes important as well. Prefer the path that was locally originated. Now, it says, or through redistribution from an IGP. And this becomes a critical point. Because if I've redistributed from EIGRP into BGP, that's going to be locally originated because it was redistributed from an IGP. And if that's the case, we're going to see that the weight for that route that was redistributed from EIGRP into BGP is going to be 32,768. And this is all very important, and it's all going to come together here shortly when we see that the BGP cost community is going to allow me to circumvent BGP's default best path selection algorithm that you're looking at right here. So let's step back to our diagram and the 4 values. Again, the type value indicating, hey, this extended community attribute is the BGP cost community, and that's how it's identified, 0x4301. Again, the point of insertion, the value is 128. We're going to see pre-best path. So pulling it back to the conversation about the BGP default best path selection algorithm, that document that we saw a second ago, and what happens when the value for the point of insertion is 128. What that means is that we are going to preempt, we're going to circumvent, we're going to evaluate the cost in the VPN v4 update that we receive at the ingress PE router. We're going to be looking at the EIGRP metric first. We're not going to look at the weight. We're not going to look at the local preference. We're not going to check to see if it's locally originated. We're not even going to look at the AS path. When we have a point of insertion value of 128, it's referred to as the absolute value. And what that means is that it's going to be evaluated pre-best path, exactly what it says. And if I walk back over here and we go back to the draft, at the IETF, you can see that the 128 value, when assigned as the point of insertion value, it stands for the absolute value. It indicates that the cost community must be considered as the first step in determining the degree of preference of that path. And again, this is sort of technical speak for BGP is not going to evaluate that VPN v4 update that has packaged into it an EIGRP route that was redistributed at the egress PE router into BGP. It's not going to say, what's the weight? And then what's the local preference? And that's how I'm going to determine which route is going to be the best. It's going to skip the BGP. And in fact, it's going to preempt it is probably a better word. It's not actually going to skip it. It's going to preempt it. And the very first value it's going to look at is going to be this cost, which is nothing more than the EIGRP composite metric value on the EIGRP route as it's redistributed into BGP. Remember, the service provider cloud in an MPLS Layer 3 VPN scenario with EIGRP as the PE to CE routing protocol, the service provider cloud is transparent from a cost perspective. There is no additional cost added to the EIGRP route when it's redistributed into BGP, or when that route as a VPN v4 update after it's been redistributed into BGP makes its way across the service provider cloud to the ingress PE router. Now, those terms might be a little confusing, so here's what we're going to do right now. We're going to take a look at the diagram of the topology that I'm going to be discussing, and these blue and green boxes are going to make a little more sense as we fill them in as we work our way through the topology. Now, remember, this is all dependent upon an EIGRP backdoor link being in play. That's where the cost community really kicks in. If there's no EIGRP backdoor link, the cost community is still going to be there, but it's not going to be a determining factor. Because without the backdoor link, which is what we're going to look at here in a second, you'll notice that there aren't multiple paths that the provider edge router needs to make a determination as to which path is going to be the best path for me to get to the network in question. So let's take a look on the command line, and our focus in this video, there's a lot going on here because this is part of a larger conversation, but we're really interested in this part of our topology, and I guess I could wrap around the prefixes, and these guys over here are included as well. You can see I've got a loopback address here of all 12s on router 12, a loopback address of all 13s on router 13. Those are the routes we're going to be working with here. But again, we're focused on this portion of our configuration. EIGRP AS99 is configured between the PE and the CE on both sides, and that's also going to be the autonomous system number we have on our backdoor link. So let me clear the screen here, and now let's get onto the command line. And remember, the backdoor link is not in play just yet. So if I'm on router 12, if I say show IP EIGRP topo, because I want to see how do I get to the 13 network. I have a single entry here. And again, if I was to expand this out, and keep in mind, remember, this is EIGRP. So if I don't say all links, I'm only going to see successors and feasible successors here. I need to say all links because it's possible that maybe I've got another route to get there that didn't meet the EIGRP feasibility condition. So let's check. No. So as promised in that diagram, the backdoor link is not up. The only way that router 12 knows how to get to router 13, to get to the 13 network at router 13 is to go via router 3, provider edge router 3. and we can see that we've got some cost values associated here in terms of the feasible distance here. I won't go into why that is not the feasible distance. That value that you see, the first value within the parentheses, that is the computed distance, and that is how I'm going to refer to it. You'll see in a lot of Cisco documentation, specifically in the CCNA curriculum from Neticat, they will call that out as being the feasible distance. That is not the feasible distance. And I have a video on my channel that goes much deeper dive that we don't have time to get into here, obviously, but I'm going to be referring to that as the computed distance because that is what that value is. That is not the feasible distance. They're the same, but they're not always the same. So we see these values that we're learning. So I'm interested in finding out more about this 13, 13, 13, 13 route. Well, I learned it from Provider Edge Router 3. So let's come over to PE3R3. Now, if I learned it across the service provider cloud, there should be a VPN v4 update that was received for that network. So let's say show BGP VPN v4 unicast all for the 13, 13, 13, 13/32. And as you can see, I do have an entry for that route. Now, take a look here at the BGP Cost Community. There it is, right? Cost : that's exactly what this is representing. This is the BGP Cost Community value. It's listed under the extended community attributes. And as I said, when EIGRP on the egress PE router, and in this case, let me call that out. The egress PE router is PE router 7, and I call it the egress PE router because this is the router out which you are going to go to get to the 13, 13, 13, 13 network. So router 7, PE7 is the egress PE router. And so now I'm going to go ahead and we're going to use these little blocks here to follow the path of this update as it makes its way over to Provider Edge Router 3 and then ultimately to Router 12. So Router 13 is originating the 13, 13, 13, 13 network. If I come over here, if I come over here to Router 13, we can see that in our configuration, if I say show IP interface brief, you can see that we've got a 13 network here, and it's just simply loopback 0. If I was to say show, let's say show run section router EIGRP, you can see that we're advertising that with a network statement, or we're originating the loopback address with a network statement. So if I come on to PE7, the egress PE router, where this 13 network is first received as an EIGRP route. How do I know that? Well, I can say show IP EIGRP VRF for customer C. Show IP route, let's see, VRF customer C. Sorry about that. Customer C. When we do the topology table, that's why it says incomplete command. I was confusing my commands there for a second. So let's take a look here. We're on the Provider Edge router for the VRF for customer C. And take a look at what the Provider Edge router learned over that interface in the VRF for customer C. It learned the 13 network, but more importantly, how did it learn it? How did it learn about it? It learned about it as an internal EIGRP route because the administrative distance of 90 is our dead giveaway right there. Here is the metric. This is the EIGRP composite metric value, also referred to by me as the computed distance earlier. So that is what the 130,816 represents. That is the cost of the PE router to reach that loopback address on router 13. So on the Provider Edge router, we have a statement. And if I look at that statement under the show run section, router EIGRP configuration on the Provider Edge router, we have a statement here that says redistribute BGP 51. And so what this is going to do is it's going to redistribute, and I apologize, show run section router BGP is what I wanted. That shows the redistribution from BGP back into EIGRP. What we want to see is this statement here. that says redistribute from EIGRP process 99. And we're talking about the VRF for customer C. So any EIGRP learned routes, excuse me, from the autonomous system number 99 that are in the VRF for customer C, those are going to be redistributed into BGP. And so I can even say right here on the egress PE router, show BGP, VPN v4, unicast all for that 13 network. Because if I'm telling you that it's getting redistributed from EIGRP into BGP and that it's going to become a VPN v4 update, there should be an entry on this provider edge router for that network. And there it is right there. Now, you'll notice that we have the BGP Cost Community here because this is in the VPN v4 update. This is what's going to be part of the VPN v4 update. You can see pre-best path is what the ingress PE router, router 3, is going to be told. In other words, this is telling the egress PE router, router 3, that if it was to receive 2 advertisements, one from EIGRP from the backdoor link connectivity, and the other across the service provider cloud as a VPN v4 update, we've got a question there, right? How is the provider edge router going to determine whether the EIGRP route is better than a BGP route? They use different metrics. And that's what the cost community allows us to do, or allows the provider edge router to do. It allows it to take a look at the internal EIGRP route. That's what that 128 stands for here. And again, I need to be clear because this also causes some confusion. If I come back to our PowerPoint presentation, remember, I said the point of insertion value is 128. It's the absolute value, and that stands for pre-best path. That's what we saw in the IETF draft. Now, why doesn't 128 just show up as the number for the point of insertion? Why does it say pre-best path? Well, iOS is translating that for us. If you were to look at other implementations like XR, iOS XR, I don't believe XR does the translation. I don't think it says pre-best path. I think it just shows you 128. And you may, again, your mileage may vary with other releases like maybe iOS XE is a little different. But on iOS, it does the translation for you. Why it does that? I can't answer that question, but what I can tell you is one possibility could be that it's more clear when we're looking at the VPN v4 update to see pre-best path instead of something meaningless like 128, because then it would assume that you've got that memorized, that you know, oh, 128 is pre-best path. So they did a great job here with iOS where it says pre-best path, but know that the value behind that pre-best path tag right there is actually 128, which is not that value of 128. And that brings us to the cost community ID. Now, the values can range from 0 to 255. In fact, you could do a route map where you set the extended community on the BGP cost community, and you could have multiple BGP cost communities, right? However, here it's 128 because 128 represents internal EIGRP routing information. If what was being redistributed from EIGRP into BGP to become a VPN v4 update was actually external EIGRP routing information, the value would not be 128 for the cost community ID. It would be 129 because lower is better with the cost community IDs. And just like the administrative distance values, when we look at EIGRP, 90 for internal EIGRP information, 170 for the external EIGRP information. Lower is better because when a router receives the same route from 2 different sources, and to be clear, longest match is number 1, right? That's the number 1 criteria when we're talking about routing and routers and making a routing decision. Longest match is going to win out. But if the longest match is the same, and in this case it would be, we're going to deal with /32s here, it comes down to administrative distance. So just like with administrative distance on EIGRP routes, 90 is going to be preferred over 170. The same is true of the cost community values. 128 is going to be preferred over 129. And I'll actually go ahead and do a quick redistribution of a connected network, and we'll see that it comes in the VPN v4 update, it'll show 129. But that is what the 128 value right here represents in the BGP cost community. It's not saying pre-best path because that's the cost community ID. The point of insertion, in other words, where in that BGP best path selection algorithm am I going to insert this value to have a decision made as to which path is the best path? But again, let's draw the conversation back here to the metric, because that's the value that gets put in the BGP VPN v4 update. It's unmodified across the service provider cloud over here to provider edge router 3, and that is still the same value in the VPN v4 update received from the originator 7777. Again, that's the router ID for router 7, PE7. And so you can see that that metric is unchanged. And so let's go to router 12, who would receive this route after it's been redistributed from BGP, from that VPN v4 update, into EIGRP, which is how router 12 is going to learn about it. Because router 12 doesn't want a VPN v4 prefix. It can't take that. It's the customer edge router. It has no idea about what VPN v4 prefixes are floating around the service provider cloud, and it doesn't care because I've got an EIGRP peering here. I want an EIGRP route. And when EIGRP is being used as a PE to CE routing protocol, and the autonomous system numbers match on the provider edge routers, and they do, it's 99, that's going to give us internal EIGRP routing information. So if I say show IP route EIGRP, my route for the 13.13.13, which is right here, has a cost of 131,072. Now, it's different from what we saw over here, which is 138.16. But remember, it goes out a port, right? It's going to be received. It's got to be sent across a transit segment there between the PE and the CE. And so the cost is maintained all throughout the cloud. And then on the customer edge router, we receive the route. And in fact, let's trace over to the 13.13.13.13, and I'll source it from my loopback 0 because we know that the 12 network is over on router 13. And you can see we go right across that MPLS L3 VPN cloud. I'm router 12. In my third octet, I use the higher router number, the lower router number. So router 12 and router 3, this is the segment between those two routers. And that's the IP address for router 3. So that's the first hop this packet takes. The packet is then given a VPN label. And then on the top of that label stack, we've got the transport label, often referred to as the IGP label. And that's how we're going to get through the service provider cloud. And then that label gets popped off at the penultimate hop, and to the provider edge router, we simply forward along the packet with the VPN label so that the provider edge router knows which VPN this is going to be associated with. And then it knows which interface out which to send this packet. And it's based off that bottom VPN label. And then we get to router 13. So everything is working fantastic. So let me go back and clean up a few things here. You can see there are other values that can be used, right, as the point of insertion values. We've got the cost community ID subfield, contains an identifier to distinguish between multiple instances of the cost community, right? And you can see that the subfield can contain different values, and the default value, if not assigned, would be half of the maximum value. And this in hexadecimal, it's like 2.1 billion because the maximum value is 4.2 billion. It's like a 32-bit value. So because again, if we were to count this out, you've got 4, 8, 12, 16, 20, 24, 28, 32 bits. Those are hexadecimal characters, each hexadecimal character a nibble. All right, so that's the last time we're going to look here at this document. Again, it's a great document to read. It tells you all about the BGP cost community. Here's the BGP best path selection algorithm, right? We talked about this. We talked about what pre-best path means. Pre-best path means I'm going to evaluate the metric that's bundled into that cost community value, or into the cost community extended community attribute, that metric value. That is what I'm going to evaluate when I'm making the determination as to which path is the best path from a provider edge routing perspective. Now, I'm going to pull up this document here. It's a 12.2 document. This document is definitely dated, very old, but it's a great document to come in and read about why the point of insertion was created and what does it do. And so take a look here. The pre-best path, or the pre-best path point of insertion, was introduced in the BGP Cost Community feature to support mixed EIGRP VPN topologies that contain VPN. In other words, we've got an MPLS Layer 3 VPN, PE to CE routing protocol is EIGRP, check, right? We're checking that box, and backdoor links. And this is where the value becomes critical. And so let's go ahead and go to the diagram here and talk about what's going to happen on Provider Edge Router 3, PE3 Router 3. You can see here, it receives this update. It's a BGP VPN v4 update, and I'll bring it up here a little bit. Now, it's going to have the BGP cost community value, and let me take a quick sneak peek back here at what that value is, 130,816. And so as a VPN v4 update, it comes in 130,816 is the metric value inside that BGP cost community. And the point of insertion is telling the provider edge router that we're not going to look at this BGP VPN v4 prefix and say, okay, what's the weight? What's the local preference? Was it locally originated? How long is the AS path? No, we're not going to do that. We're going to preempt that. We're going to circumvent it. And the first thing we're going to do is we're going to evaluate this prefix, which is a VPN v4 prefix, against, and let me pull that back a little bit and center it, against this update that's going to circle around this way and show up here as an EIGRP update. Again, remember, the EIGRP peering between router 12 and router 3, they're exchanging EIGRP routing information. So when this backdoor link comes online, this 13 route is going to be learned on router 12. We're going to see it in the topology table, in fact. And you're also going to see it here on router 3 PE3 in the topology, in the EIGRP topology table for the VRF for customer C. And it's at that point where the provider edge router PE3R3 needs to make a decision. Well, I've got two prefixes, or I'm sorry, I have the same prefix I've learned from two different sources. And I need to be able to compare that. And the BGP cost community is what makes that a reality. It allows the provider edge router to say, hey, on the VPN v4 prefix, I know it's a BGP prefix, but that's not how I'm going to evaluate whether or not that's the best path. I'm going to make that evaluation based on the metric, the EIGRP metric. That's all BGP cost community is going to do for us here. All right, well, let's go ahead and let's clear the screen. Let's get back on the CLI and let's bring this backdoor link up. So I'm going to come over here to router 12. And again, to show you the backdoor link isn't up right now, if I say show IP EIGRP topo for topology table, all links, you'll see there's only one path to get to the 13. We saw that earlier. Now, everything is already configured. The EIGRP configuration is set up. I just need to get into interface gigabit Ethernet 010 and say no shut to bring that link up. And I'm going to come over to router 13 and I'm going to do the same thing. We're going to get into global config and we're going to say interface gigabit Ethernet 010 and I'm going to say no shut. And we should see the adjacency come up here within the next few seconds, and there it is. And you can see the interface is up. Oh, I'm sorry, the adjacency should be up here in a second, and there's the adjacency coming up, so we're good. So I'll save the config here, and let me save the config over on router 13. So let's come back to router 12 now, where, again, I ran show IP EIGRP topo, and I saw just one path. and we'll put the all links on here right out of the gate, because we're going to be able to determine whether or not this route meets the EIGRP feasibility condition by looking at this output. So what do we have now on the customer edge router? Well, the customer edge router has a single successor here, and it's no longer the service provider's PE3 R3 router. No, now router 12 is preferring the EIGRP backdoor link. And this is a problem. We don't want the backdoor link being used. You can see here the backdoor link is listed in the all links output, but is it going to show up if I say show IP EIGRP topology? And the answer is no. But why is the answer no? And so if you're looking at the all links output and saying, well, yeah, it should show up because the reported distance here of this non-feasible successor is the same as the current computed distance of the current successor. But that is one of the tricky things about EIGRP. And when we talk about the feasibility condition, feasible successors, non-feasible successors, reported distance, and the computed distance. Remember, the feasibility condition states that in order to be a feasible successor, the reported distance must be strictly less than the current computed distance. Again, that must be strictly less than. And I say strictly less than so that I'm clear that it doesn't mean, oh, less than or equal to, because that is not what the feasibility condition states. So when I say show IP EIGRP topology and I hit enter, we are going to see a single successor, because this path through the PE3 R3 router does not meet the feasibility condition because the reported distance is not strictly less than the current computed distance. And there you go. And so that's why we don't see that second path from the PE3 router here in the show IP EIGRP topology table. Now, the same would be true over on router 13. Let's validate this. Show IP EIGRP topo, all links. And for the 12 network, I should see two paths. But yet here again, the reported distance from the PE router, remember, and that reported distance was bundled up, right? That's its cost to reach that network, is equal to the current computed distance of the successor. That is not going to meet the feasibility condition. If I pull the all links off and we look at the EIGRP topology table, we have a single way to get there. Now, something else has happened here. Remember, the updates are now being sent for the 13.13.13 around the backdoor link over here to router 12. And so when that update reaches router 12 sees that as an internal EIGRP route, like we have right here. And let me go ahead and we'll make a copy of this. It sees it as an EIGRP internal route. And so it's going to do what EIGRP was born to do. It's going to advertise it to its buddy here, and I'm going to get rid of the 12 network. It's going to advertise it to router 3 because it has an EIGRP peering with router 3, the provider edge router. So now router 3 has a dilemma. I've got a network, or I have an advertisement to get to the 13 going back to router 12 this way, and that's an EIGRP advertisement for the 13 network. But then I also have an advertisement that came across the cloud, the service provider cloud, as a VPN v4 update for that exact same network. This is where the BGP Cost Community comes into play, because the BGP Cost Community is going to look at the metric value here and the metric value for the EIGRP learned route that it's going to have, and it's going to base its comparison off of those values. So let me clear my screen, and I'm going to get the metric value here in just 1 second, and I'll just say METRIC. And let's go back to the command line. Let's come over to PE3R3, and let's say show IP EIGRP for the VRF for customer C. And this was the command I was running earlier when I wanted to say show IP route VRF customer C. So I say show IP EIGRP VRF customer C, and I want to see the topology table. And in fact, I want to see all links. And so let's come down here and take a look at what we see. And so you can see that on the provider edge router 3, it is getting 2 EIGRP updates. One is VPN v4 sourced, and there is that metric value that we're very familiar with. And then here is the sourced, the update coming across. That's our backdoor link advertisement. And there's the metric value that the provider edge router sees as advertised by the internal EIGRP route being advertised from router 12, the customer edge router. So 131.072, 131.072, and this is it. I mean, this is the crescendo here for the BGP cost community. That is what it's going to facilitate. And so it's basically, and I'll use the word trick, it's going to trick the provider edge router, and it's going to trick the BGP process into simply looking at that value and that value, pre-best path. We're not looking at weight. We're not looking at local preference. We're not checking to see if it's locally originated. Pre-best path means I've got 2 updates coming in for the same route, the same subnet mask length. I need to compare these two. But how would this typically go? How would you typically have this decided? It would be the EIGRP learned route, right? Because if this router learns the same route from 2 different sources, we would look at the administrative distance. And what's the administrative distance for internal EIGRP? I've got it there in the diagram. It's 90. Let's pull this up and say, what is it going to be for a VPN v4 update? Remember, a VPN v4 update is an IBGP update, and that has an administrative distance of 200. So all things being equal, if this was a regular conversation about router 3 gets an EIGRP route for the 13, and it gets a BGP route for the 13, an IBGP route for the 13, the EIGRP route is going to win out. And that is not what we want to have happen here, right? What we want to have happen is we want BGP on the provider edge router to compare the EIGRP learned route from router 12 that it's getting through the backdoor link, and then the VPN v4 BGP update that it's getting from across that service provider cloud. And we want the provider edge router to make the determination based on the metric. And when you look at this EIGRP route, 131,000, is greater than 130,000. And this is the beauty of the cost community extended community attribute. Because as I look at this scenario right here in front of us, this becomes a simple fix because it turns it into an EIGRP layer 3 traffic engineering conversation at this point. Because if the provider edge routers are evaluating the best path for these EIGRP learned prefixes, and even when the EIGRP prefix is redistributed into BGP and shows up as a VPN v4 update, it's still going to look at it and evaluate it and make a best path determination using the EIGRP metric. Well, then all I need to do is do some layer 3 traffic engineering, adjust the delay in the locations that I want it to be adjusted in so that the service provider cloud is the preferred path, and the backdoor link, while still there, is no longer the preferred primary path. And so let's confirm our primary path right now. Let's come over here, and we could even see it as simple as show IP route EIGRP on the customer edge router. Is it going to go to the service provider cloud? Absolutely not. It's going to go across that backdoor link. And again, that 10, 12, 13, 13, that's the backdoor link. If I was to do a trace to the 13 network and source it from my loopback 0 address, we're going directly to router 13. Again, the backdoor link is going to be preferred by the customer edge routers. And this was the challenge that BGP Cost Community was created to address. Because here's the problem. Now all I need to do is manipulate the delay. So if I come over to router 13 and let's just make sure show IP route, EIGRP, and you'll see that the preferred path, absolutely the backdoor link. If I was to trace over to the 12, and again, this is just for completeness here. We know it's going to do this, but we want to make sure that it's doing exactly what we think it's going to do. And there it is. So if I look at my diagram, how do you do layer 3 traffic engineering with EIGRP? And I kind of gave the answer away earlier. It's the delay. Well, okay, where do I make that change on the delay? Well, it's on the backdoor link that I would increase the delay value here, and I would increase the delay value here. And I don't have to go crazy with the delay value. I just have to increase it enough so that this 13, 13, 13 route, when it makes its way over here and then comes in here, I'm sorry, I shouldn't say, let me pull that back just a little bit. There we go. When that 13 route shows up here on router 12, the customer edge router, this router is not going to say, oh, well, I'm sorry, let me rephrase that. So when the 13 network shows up over here on router 12, since we've manipulated the delay, we're making this look less attractive, less preferable, worse, i.e. a higher EIGRP cost than going this direction, right? Because right now, if we step back to router 12 and we look at the decision that router 12 is making, and we can see that in the topology table of all links, right? For that 13, I'm sorry, I'm on router 13 here. We could talk about it from router 13's perspective. It's the same conversation, right? So router 13 sees the 12, and where does it see the lower cost? Right, the backdoor link is a lower cost. The cloud is going to come in at 131.072. It'll be less preferred. And so we need to make this decision easy for the customer edge routers so that they don't prefer the backdoor link. And that's going to simply be going into global config, into interface gigabit Ethernet 010, that backdoor link interface. And I'll simply put the delay at, let's say 10 should be enough. And now let me come over here to customer edge router 12, interface gigabit Ethernet 010, and let me tweak the delay to 10. So now, if I come over here to, or actually we could stay right here on router 12. So now if I say show IP route EIGRP on router 12, let's take a look and see what path is all of a sudden going to be the preferred path. And there you have it. And take a look. How long has it been in the global routing table on the customer edge router? 8 seconds. And that tells us, without a doubt, that this route was just installed 8 seconds ago into the routing table because the backdoor route no longer is the best. It's no longer preferred. So now the conversation has changed because this cost is more preferred. The backdoor link is no longer the preferred path. In fact, if I was to trace to the 13, 13, 13, 13 and source it from my loopback 0 address, we now are going over the MPLS L3 VPN cloud. And the reason that we can get away with that, the reason we are allowed to do that, is because here, where BGP, if it was making the decision between these two routes based solely on BGP best path selection criteria, weight, local preference, the locally originated route is going to win because the locally originated route is going to have a weight of 32,768, right? And so we don't want that. We want the comparison to be between the metrics here, the EIGRP metrics to be exact. And so that's what's happening on the PE router. So the PE router says, yeah, the VPN is the way to go. We now have the cost community value, the delay value on the backdoor link set so that the customer edge routers see things the exact same way. And the customer edge routers are no longer going to prefer that backdoor link. They're going to prefer the service provider cloud. And here, if I was to say, again, just to confirm, trace over to the 12.12.12.12 and source it from my loopback 0 address, which way are we going to go? You got it. We're going to go over the service provider cloud because the conversation becomes an EIGRP layer 3 traffic engineering conversation. Because we know on the provider edge routers, we know that it's not making a BGP decision here as to which path is going to be the best path. Because if it waited for this EIGRP route to be redistributed in and assessed the two of them based off of the BGP criteria, this redistributed, locally originated route with a weight of 32,768, that is going to win the BGP race to become the best path. And that would be a problem because now the provider edge router thinks, oh, well, my best path to get to the 13 is this way and not going this way. And that is not what we want, right? Because 12 is going to come this way with the traffic. And so the cost community allows all of that magic to happen on the provider edge router. All right, well, let me step back to the deck here because I think that that is going to wrap up our conversation. So a couple things as a review. We talked about the BGP cost community specifically in the context of an MPLS layer 3 VPN where EIGRP is being used as the PE to CE routing protocol. Remember, the point of insertion is not its own thing. It is a single octet value that is in the BGP cost community extended community attribute. We took a look at some different values, but there's one thing I didn't do that I promised you I would do. We saw the cost community ID of 128. In fact, if I come back over here to PE3R3, and I say show BGP VPN v4 unicast all, and let's look at that 13.13.13.13, oops, not 31, 13/32, right? I showed you this value here for that cost community ID, and I told you that that 128 is not the 128 we talked about with pre-best path. This is its own value, and here in a Cisco implementation, that value represents what? Exactly. Internal EIGRP information. So let me do this. We're going to come to router 12. I'm going to go into global config. I'm going to go into interface loopback 100. I'm going to create my favorite standby loopback address of 100, 100, 100. Now, the only reason I say standby is it's typically this is my go-to when I need another loopback very quickly. We're going to make it a /32 as well. But I'm not going to create a network statement for that in the EIGRP configuration. No. What I'm going to do is I'm going to go into router EIGRP 99 and I'm going to say redistribute connected. Now I'm not going to do a route map to lock it down to just that. We're just going to look at that prefix. But now that I've redistributed that prefix, the 100, 100, 100, 100 into EIGRP, if I come over here on router 13 and I say show IP route EIGRP, is it feasible that I should be seeing an external EIGRP route for that network? And I do. So let's come on to the provider edge router where for internal EIGRP information, we see 128. Let's take one last look here. I'm going to, not configuration mode, sorry. I'm going to say show BGP VPN v4 unicast all for the 100, 100, 100, 100. Because remember, this is going to be an EIGRP learned route across that VRF-aware EIGRP process on the VRF interface between customer C's CE router and the provider edge router. So just like EIGRP always does, it learns this route because we've redistributed it from a connected network on the customer edge router into EIGRP. So customer edge router 12 is going to go ahead and send an update for this network over to the provider edge router. They have an EIGRP pairing. That's going to get redistributed from EIGRP into BGP. It's going to become a VPN v4 update because, again, in the VRF, we've got that route distinguisher 64-bit value that's prepended to this IPv4 prefix. And we have a VPN v4 update. But most importantly, our cost community ID is now 129. And that represents external EIGRP routing information. Because if two VPN v4 updates showed up on a provider edge router, both for the same network, both for the same EIGRP network, and one of the cost community IDs was 128 and the other was 129, the cost community of 128, which is lower, is better, is going to be preferred because it's internal EIGRP routing information. All right. Well, that is the BGP Cost Community in a nutshell. I hope you've enjoyed this video. If you like the level of detail here, you're really going to enjoy my MPLS for network engineers, which is going to be coming out at INE. And if you've got an all-access pass, you're going to have access to that series. All right, I thank you so much for your time. I hope that you learned a lot in this video. I hope this was beneficial for you. Again, BGP Cost Community, that's what it is. Thanks so much for watching, and have a great weekend.